Good day everyone, wherever you are. My name is René Jonk and welcome to another brief educational video in the realm of assigning risk and adequacy to subsurface parameters with a focus on oil and gas prospecting. In the last video we talked about methods of assigning geological chance of adequacy, which is really 1 minus risk, to subsurface risk elements. In this video we'll elaborate a little bit on the use of geological chance of adequacy, geophysical chance of validity, well chance and commercial chance of success. These are all different risk assessments and each generates a unique chance of adequacy. This is very important to keep straight, as performing any type of audit on historical drill well performance in order to gain confidence for future outlook on expected results may result in significant errors if these different risk profiles are being confused. So let us summarize the geological assignment of chance of adequacy once more. This involves the multiplication of all independent geologic risk elements, properly benchmarked against their geological risking minimum. There are a total of 9 independent risk elements, which can be grouped as follows. Charge, which is the ability for multiple trap volumes of hydrocarbons to access the trap. This is composed of the components of source presence, maturity, migration, and timing. Retention, the ability for connected volumes of hydrocarbons to backfill from a trap crest, which is composed of the components of trap and seal. And finally, reservoir, the ability to encounter hydrocarbon volumes in permeable pore spaces, which consists of components of reservoir presence and quality. And finally, there is a key component which is often forgotten, which is commodity risk. This is something you apply to success gate outcomes and considers the chance of buoyant but undesirable commodity fluids. These may include, for instance, hydrocarbon gas, if that is a non-commercial fluid, significant CO2 presence, or biodegradation-induced heavy oil. So combining these elements against geological risking minima generates a geological chance of adequacy. The combination of all the risking minima typically corresponds to something around a P99 success case volume if you run a probabilistic distribution of success case outcomes from these parameter distributions. For communication purposes, it's always important to quote that minimum volume that this geological risk applies to, which is the outcome of the probabilistic assessment rather than an input into the risking. More useful, however, is to also communicate the outcome chances of a prospect in terms of the main components being considered: charge, reservoir, and retention. Well, what do I mean with that? Well, it's best to show you with an example. So let's say I have a prospect with an overall geological chance of adequacy of 15%. Rather than just stating I have a 15% chance of finding a minimum hydrocarbon volume, it's more useful to articulate the chance for different types of well outcomes. In this case, my major risk is reservoir. Chance of finding at least 20 meters of sand of at least 10% porosity. And thus the chance of outcome for the prospect is 70% not finding adequate reservoir. The other risk factor is seal. Chance of adequacy of 50%. So if sufficient reservoir is encountered, half of the cases will contain significant shows but no connected hydrocarbon volumes. So this is what a probability of outcome for that prospect looks like. Now let's say we have another prospect with a geological chance of success of 20%. In this case, the major risk is the presence of source, 50%. So there's a 50% chance of encountering a wet reservoir. The chance of finding accumulation is 50%, but in this case there is a 60% chance of the commodity being gas, which in this particular example is a non-commercial commodity. So there is a 30% chance of the outcome being gas and a 20% chance of the outcome being oil. So these are two prospects with very different drill well likely outcomes, even though the chance of success is not hugely different. So that's all good so far, but that's geological risk, i.e. assigning a combined chance of all 9 geological risk elements passing a minimum hurdle to deliver a minimum volume. Well, can you come up with a different way of risking prospects' chance of success? Well, yes. You can use seismic attributes and assign a chance of validity to a set of seismic attributes being indicative of the presence of hydrocarbons. This is a completely separate method for assigning geological chance of adequacy based on the combined risk of all the 9 risk elements. There are 3 sets of attributes and observations that we'll usually look at to contribute to the seismic-based risking, being section view attributes, which include the presence of flat events associated with hydrocarbon water contacts, amplitude change or phase reversal above the inferred contact, and frequency loss within the column. Met-based attributes, which focus on relief conformance of amplitude, and finally the quantitative conversion of amplitude variation with offset angle, AVO or AVA. as these properties relate to changes in near offset reflection coefficient, which is a proxy for impedance, and the AVO gradient, which correlates to VPVS change across the interface between hydrocarbon-bearing reservoirs and the surrounding non-reservoir rock. For each of these attributes, there are pitfalls, i.e. the confidence in positive observations is dependent on data quality and the existence of calibration. Stratigraphic traps in particular can give false positive responses of pseudo-flat events and down-dip relief conformance related to lithology and reservoir quality changes. And AVO is a very non-unique signature that is a combination of elastic properties of reservoir and seal. When uncalibrated to wells, its confidence is low. So what do you do when you are risking a prospect chance success? Do you go geological or geophysical? Well, really you should do both, provided the rock physics and data quality allow for evaluating DHI attributes with some confidence. And preferably you do it as independently as possible, although that's very easier said than done, because very often bias creeps into the geological risking in the presence of seemingly positive DHI attributes. And realistically, a prospect in DHI setting has already been high graded in the first place because it has some redeeming geophysical attributes. Sometimes I hear people say, well, my geological chance of adequacy is so different from the DHI chance of validity, so one of them must be wrong. Well, that's really not how you should think about ranking and risking prospects. You should treat these really as two completely independent, valid perspectives. Typically, in early exploration methods, the geological method tends to be more viable, whereas once a play has been calibrated and established against seismic attributes, the DHI chance of validity method tends to be the one that more accurately ranks and predicts prospects. When you're in that in-between space here, you can use Bayesian statistics to provide this truly independent chance of observations. You can combine the geological chance of adequacy with a DHI chance of validity to obtain what's called an integrated success chance, which may be a useful way to get a better ranking of prospects in that in-between space where both geologically and geophysical methods may be equally valid. It is perfectly acceptable to have two prospects with opposite views on geological and geophysical chance of success. This is actually a really useful space to operate in, as testing the prospects should help you decipher whether one of the workflows is a more confident predictor of the outcomes for future drilling. For instance, I have prospect 1 here with a low geological chance success but with positive DHI attributes, and prospect 2, which is a high geological chance success but negative DHI attributes, and they both come out at about the same integrated chance of success. Okay, got it. Geological chance of adequacy and geophysical chance of validity are two independently different risk assignments, and I can potentially combine them to generate a single integrated chance of success. Well, that's about it, right? Well, not quite. One item where I often see teams and companies do a poor job of auditing well results against pre-drill risk assessments is the failure to distinguish the prospect chance success from the drill well chance success. Well, aren't those the same thing? Well, not really. First, the risk elements apply generically across the prospect, but geology is very rarely uniform across the prospect. One very important risk factor to consider for a drill well is whether the overall chance of adequacy for reservoir across the prospect applies to the drill well location. In fact, we are often quite good at finding the very best reservoir-prone part of a prospect for the first drill well we drill in a prospect. If successful, a recommended appraisal strategy should be to test the lower limits of the reservoir, i.e. you should drill an appraisal well to a discovery in what's interpreted to be the porous facies that might still just about be contributing to a reservoir. So it's possible to have a drill well chance success that's significantly less than the prospect chance success, which could be 1, even if you're appraising within the limits of a known discovery. This is very important to communicate to management, as often resource volumes can artificially balloon following a successful discovery, where everybody's going to adjust the high side reservoir parameters, only for those volumes to subsequently be downgraded as the appraisal wells are drilling more marginal locations. The other key influencer on drill well success versus prospect chance of adequacy comes from the column height distribution used in the assessment. This is really important. In our example, we are risking against a minimum column height of 50 meters. However, the chance of success for ever increasing column heights will diminish as a function of the column height distribution that you use in your assessment. While a probabilistic volumetric success case probability curve is driven by the combination of all volumetric ranges, gross, net to gross, porosity, saturation, and lots of others, you will find that the strongest correlated to the distribution is the column height distribution that you used. As such, the increased volume correlates approximately to an increased column height, to the point where we can correlate volumetric distributions such as P90, P50, and P10 to the approximate column heights corresponding to these thresholds. As such, the drill well chance of success only equals the geological chance of success for the P99 volume and the P99 column height. For instance, if I drill at a P50 location, which is about the P50 column height, my drill well chance of success would be diminished by 50% compared to the geological prospect chance of success. So think about where you place the well and how that well chance of success compares to the prospect chance of success. They are not the same things. And then finally, there is the matter of geological chance of success versus commercial chance of success. Again, it is important to distinguish between the two and be very clear and communicate at what chance of success you are talking about. Commercial chance of success is simply related to the minimum cutoff of some recoverable volume that's deemed to be commercially viable. Obviously, that definition of that volume is highly dependent on what fluids you encounter, what pressure and temperature are, what type of development plan you consider, and ultimately what the cost of the development looks like. So these are very difficult to predict, but it's useful to at least put a benchmark of what is deemed a commercial volume early on, so that you can communicate the chance of encountering a commercial benchmark relative to the geological chance of success. Such a discussion may also drive where you will place a well, and whether you're testing the geological or commercial validity with the well, and what really the well chance of success is. If it is desirable to test the commercial quantity, the drill well location will need to be placed down dip far enough to test the likely commercial threshold, and therefore the drill well chance of success can be significantly lower than the geological chance of adequacy of a prospect. Alright, that is a lot of information in a short video. I'm sure there's lots of questions and thoughts of, could you explain it a little bit more? As always, we are open for suggestions for future topics of videos, and obviously the easiest way to progress in this arena is to drop us a line. We are here to help training your teams, provide independent review of your portfolio, or generate a portfolio for your organization. Alright, thank you very much for your time, and catch you on the next video.